Good afternoon and welcome to this technical guest session by Mr. Kapil Budhia. He is in charge of the Pune Center of Klingelnberg, which is an organization which is into uh, software development, application development. More about himself and about the organization. He is the best person to introduce himself. Hopefully, all of you will enjoy, and I expect a lot of participation from the students and good number of doubt solving queries and all. He's an expert and he's an alumni of CDAC. So you should be aware that he's an alumni, so he knows nitty gritty in and outs of CDAC training and all. And hopefully there are a lot of takeaways and you will enjoy this session. Welcome Kapil once again.
Hey, thanks, Keshav, for providing this opportunity. It's always great to interact with youngsters who are very energetic and want to make the mark in the software industry. So I'm really delighted that I'm here and talking to all of you. So a very warm welcome to all of you. I'm guessing that people are spread. Most of you are spread all over India. So greetings from Pune then. Now, this is a bit awkward because I haven't done a session of this scale with so many participants through a Zoom meeting, through a web conference call. So it's always nice when I do it face to face from your facilities in Akudi. I can see every one of you and I can judge your facial expressions and realize whether you are loving this or you're absolutely hating it. So I can sort of model things that way and maybe change something more dynamically during the session. But in this case, I think it's going to be a bit monotonous. I'm going to continuously speak. So what I'm really hoping, in order to make this a fruitful session for all of us, I really hope active participation from your end. Please, I don't know what's the means to, but there might be something like raising hand, or you can feel free to jump in and intercept me at points where you think you need more clarification or you have a doubt and you would like me to throw some light on that. So I'll be very more than happy to answer your queries as we tag along. Yeah. So once again, welcome, and we can get started. So I'm going to share my screen. I see there are about 190 participants, and that's great. Okay, so I'm hoping, Keshav, you can hear me.
Yes, sir.
Oh, that's great. So I don't have to repeat myself. Okay, so I'm going to share screen. Say, yeah, share the screen. Okay. So I have a presentation, which is 2 slides. Yeah. So that's great, isn't it? So a bit about myself. I'm heading the digital unit here at Klingelnberg, India. Maybe I can give a very short reference to what Klingelnberg is. So Klingelnberg is about a 160-year-old company. It's a German firm. Its headquarters are in a small town called Hückeswagen in the north of Germany. And there are other development centers in the south of Germany, at Lingen near Karlsruhe. And then there is a digital development center here at Pune, which is headed by me currently. Klingelnberg is basically into the world of making machines, predominantly for game manufacturing. This might sound very manufacturing or mechanically, but we do a whole lot of software. Yeah, so these machines are very costly machines. you may be selling one of them here in India at a price of 10 crores, 15 crores, and so on. So, there's a lot of software that goes on this machine to make these machines work uninterrupted all the time, 24/7, 365 days a year. So there's a lot of responsibility when it comes to developing software. And, this is what the software unit in Klingelnberg does. So we develop all kinds of softwares related to, path algorithms, where the machine should, how the machine should move, design algorithms, how the gear must be designed. So we have our own CAD packages for designing gears. We have the concept of closed loop system. And what we specifically do here in India is we are a digital competence center. So the idea is that, with this boom of Industry 4.0, we are venturing into this space with all our potential. And this task is basically is my responsibility. So we are developing products in the space of industrial IoT, for smart manufacturing, for everything that relates to shop floor, cloud computing. So there's a lot of things that we do in the cloud. For example, collecting data from the shop floor. And then the idea is, that we do machine learning algorithms to improve processing times, to improve optimization, to improve resource utilization, and so on. So that's what I do at Klingelnberg. I can give a bit of history about me. So, I am a graduate in maths. So, I'm one of those fortunate ones who hasn't done engineering. So I did my maths. I did my bachelor's in maths in the year 1999. And then I pursued PGDST from NCST. And this, I think, later merged with CDAC. So this is how I'm an alumni. So that time it used to be a one-year course, I remember, and that is when I got introduced to computer science for the first time in the year 2000. And I really haven't looked back. And then I went on to do my MTech from IIT Bombay in computer science again. And I was landed with a job here in Pune with a company called Fluent. They were into computational fluid dynamics. So a lot of geometric algorithms that I crunched during that period, about 6 years. Till 2010, I worked with Fluent. Then I had a short stint with a startup for online marketing. And then I moved to UK with a new company called Renishaw, which was into business of metrology. So I worked there for about 6 years. And then now I came back in 2016, 17, and hence, since then I've been working with Klingelnberg as the digital head here. So that's about me. You can check my LinkedIn page. I will share that towards the end of the session. So that's me. So what is that I'm planning to do? I plan to. The idea is to do a technical session where I can explain the basics of writing an algorithm. So this is going to be a very hands-on session. We'll take a problem statement to start with, a really simple one that I expect everyone to be able to solve. Okay. Can you see my screen?
Yes, sir.
Yeah, okay. If time permits, I'd like to talk a bit about Git. I know I'm guessing there's a course on Git basics or Git for the CDAC. Am I correct? Can somebody from the students answer that question?
So we had Git basics in our software engineer means in concepts of programming session. There it was a subtopic, a small introduction related to Git.
Perfect. Okay, it would be nice to sort of mention your name and then sort of speak so that I know who is talking.
Yes, sorry, I forgot to introduce. So myself, Vikas Patham.
Okay, great, Vikas. Thanks.
Thanks.
And then, we mingle this with testing. So it's to me, to me, this is the most basic element of being able to write code, a piece of code that works. Yeah. So testing is an integral part of your development. Yeah. If time permits, I would like to talk a bit about, what companies are looking for when they come for placements, specifically, for example, what am I looking for in the candidates? Yeah. What are the kind of candidates that I end up hiring? So you can ask me questions in this regard, and, I'll try to answer to the best of my knowledge. And, you can have any questions and feedback to this session. I would really appreciate it. So if there's something you would like me to improve or add or remove, I'll be more than happy to take your views into account. Yeah. So I'm hoping everyone can follow me. Am I too fast? Am I too slow? Or am I fine? Perfect.
So it's perfect.
Okay. Cheers. Thank you. Okay. So now the presentation part is all over. Yeah. Okay. So I was just writing the problem definition when I joined the meeting. So maybe I just did half of it. So let's say the first problem that I want to look at is, given an array of integers, write a function to return the minimum element from this input array. Yep. Everyone gets the problem statement? Yeah. So the idea is that, you are going to be given an array of integers. You're supposed to write a function that returns the minimum element from this input array. Now, this one sounds, simple, and it is simple. But one of the things that I've noticed when I go for interviews, I really find it that a lot of candidates, either due to pressure or just because they've never done hands-on, they really struggle to write even this piece of code. And one of the advice from me would be that you really need to get your hands dirty. There's nothing like mugging an algorithm. That concept does not exist. Yeah. So if you are sort of doing through that way, I would say it's high time you start getting your hands dirty. Things you actually write, make it work. And this is absolutely essential. I can share a very small, experience from my own career. I was a math student and I did not know anything about computers. Yeah, so to me, a virus in computer was almost similar to a biological virus in a human. This is what I knew about computers in the year 1999. And then I wanted to pursue a PhD in maths, but I decided for whatever reasons, mostly economical, that I should change from maths, and instead of doing a doctorate, I should go for computers. And this is where I gave my entrance for PGDST. I got landed in the Jew Center, and I started doing this computers course. And I remember the first 2 months, everything was an absolute bouncer to me. The pointers and stuff like that. I was a very abstract guy doing maths all the time. Yeah. And this was really something very different. But I remember this concept called MGPT there. That time, I don't know if it exists anymore. Keshav, I believe MGPT isn't there anymore, right? But that time there used to be this concept of MGPT where you have to be able to crack 2 algorithmic problems in a machine-graded programming test. And I remember the first time I gave that exam, after 2 months, I couldn't finish writing my program, forget alone compiling it and actually making run. And, this is where it was sort of a shock to my internal system, because things were sort of easy till then for me. And I really took it on to this challenge. And, I must have wrote like 100 algorithms myself, solved them, struggled, right? Broke my head over days, and eventually, got to a point where I could clear this MGPT. Yeah. And I believe when it comes to algorithms, there's no shortcut. Yeah. You have to get your hands dirty. You have to struggle. You have to go through some sleepless nights with some of the problems, and eventually you emerge from there. Yeah. So I would say, whatever time is left for you, please take it as a challenge that you should finish at least 15 to 20 algorithms. Nowadays, there's a lot of sites you can go to, HackerRank, HackerEarth, and so many where you can practice algorithms online. Make sure that you always get it correct, yeah, and you always do it yourself, and there's never a copy, even slightest, from anywhere. Right. So let's get started with this. I'm pleased, this. I don't want this to be a very monotonous session. So ideally, what I do is I don't solve it, and it makes no sense for me to write this. I typically expect, students to prompt me of how to get started. Yeah. So, so I really expect. Just 1 second. Sorry, give me a moment. So can somebody tell me how should I get started? Do you know, have you ever worked with Visual Studio before?
Yes, sir.
Yeah, so who is this?
Sir, again, Vikash Batham, sir.
Hi, Vikas. So tell me, how should I go about?
So, are we doing in Java or C++?
Yeah, this is C#, but did you all have a .NET course?
No, sir. We only had Java.
You only had Java. Okay, fine. So in that case, have you worked with Visual Studio before? Was there any introduction to Visual Studio?
Sir, in web technology, we used Visual Studio for Node.js and for all that stuff. And for Java, we used Eclipse.
Okay, fine. So what we are going to do is we're going to write a C#. We're going to create a C# program. And believe me, when it comes to the language, Java and C# to a large extent are very similar. Yeah, so you would not see much problems with the syntax. So let's say in this case, I'm going to create a .NET Core Console application.
Hello, sir.
Yeah. Yes.
Can you increase the font size, sir?
Yeah, do so.
Okay, thank you, sir.
So this is CDAC. Let me once get to the file where the code is. Yeah. So we name this CDAC. Say algorithm session. Okay. Let's say create. Okay. So now, is this visible or?
Yes, sir. It's visible.
This is visible now?
Yes, sir.
Yes,
Yes.
sir.
Perfect.
So one more request. Can you please turn on your camera that it's more engaging to us,
Okay.
if possible? Yes, sir. Thank you so much,
Yeah.
sir.
So now everyone can see me?
Yes, sir.
Okay, perfect. Right. So we want to create this. I want to turn this off now. It's occupying. This thing is occupying my real estate. Yes. Okay.
Hello, sir.
Yes.
Sorry to interrupt, but I want to inform you that some students are responding through chat. So it will be beneficial if you can open chat window on your end.
Okay, sure, I can do that.
Yes. Otherwise, if all speaks at once, so it may cause chaos.
Yes, that's correct.
Thank you, sir.
Okay, so I see a lot of you saying VS Code we use for C++. Perfect. Okay, that's great. Okay, sorry, I was missing all this. Yeah, there's a lot of fun going on in the chat there, and I was missing it. Sorry. Okay, so we create this thing called. So you have the concept of namespace also, I believe, in Java. Yeah, if you have it, let me know. So I'm sort of trying to get used to this Okay, to this chat thing. Okay, so let's first rename the class with something more meaningful. Let's call it algorithms. Okay, and so, you know, as a first thing, what we can do is we can simply go and compile this. Yeah, so we can build it. It takes a bit of time at the beginning because, you know, it's restoring NuGet packages. So just like, you know, in Java, you would probably need some jar files. Build is completed. Yeah, and if we run it, then it prints hello world. Okay, perfect. So we're able to compile and run a .NET Core project. That's great. Okay, now let's get back to, you know, let's get down to business. So we need to write this function. So can somebody tell me, you know, what would the signature of the function of this method look like? So instead of Vikas this time, let's see, Rohit. Is there Rohit Sopan in here? Is there Rohit in here? Okay. How about Rashi Gundapwar? Okay, that's not going very well. Is there Barkha Sunil? To everyone, you know, it's no fun me really writing this, you know, it's not going to be fun for you at all. So I would really encourage everyone to participate. Don't be worried, you know, don't be shy or worried or anything. Tell me whatever you know, we'll take it from there. The session is for you, not for me. Is there only Vikas in here? Am I still in the session?
Yes, sir, you are.
Okay, thank you. So okay, anyone from these people, Shivdan, Dilip, Mayur, Divyanshu, Gundapur, Rashi, Nandkishore. Keshav, it looks like they don't want to talk to me.
Yes, guys. Anyone? Why you are not responding? Yes, yes. Pratik, please unmute yourself.
Hello, sir. Hello, sir.
Yes, Pratik.
So first we define the function, this algorithm.
Yeah, do you know the question, Pratik?
Yes, sir.
So we have to write an algorithm to compute the minimum given an array of integers, right? So we are trying to write a function here. So my question is, you know, what is the function signature? Yeah. Do you understand what I mean by signature?
Arguments, sir. Okay?
Yes, arguments and return value.
Yes, sir. Return value int.
Int, perfect.
And
then function name.
Function name, anything, get min, get max, anything.
Yeah, so
Because
let's call
because
it,
we find out the minimum value. So minimum value
right. So let's call it minimum. And what would be the input to it?
argument size of the array and int array.
Yeah, so we need to give an array, isn't it?
Yes.
So,
Int array and it's the size.
right. So in C#, the size is part of the array object itself.
So
Yeah, so you don't need to pass the size separately. Yeah. Let's make this a public function method so we can call it. Yeah. Now can someone help me write this algorithm actually?
Hi, sir, Mudit here.
Who's this?
Mudit.
Mudit. Yes, please, Mudit. Tell
So
me.
first of all, we have to declare some variables to store this list in array.
Okay, help me out. Which list? So I need to create a list.
So basically, you have to declare some variable, like
Okay. Of what type?
array type, integer array type.
Okay. Int.
sir, first we store the value of 0th element of array in some variable.
Say it again. So you want me to store the minimum, the first element of the array.
Yes, sir. 0th element of the array.
Okay, and what should I name this variable as?
Anything into first 0th element and
Anything or some name?
int res result like this.
It's not a result, is it? Is a result is a outcome of a computation.
Yes, sir.
So what is it? What is this variable holding?
Int 0th element.
Okay, so what should I call it?
Let's say it minimum, sir. Num1.
Int
Num1.
Num1. Yes, sir.
Why 1?
Because in which we can store the 0th element of the array, sir.
But why are you calling it num1?
Because we will compare it with num2.
And then there's a num3.
Depends. If we will take the minimum of num1 and num2, and then we'll compare that with num3. So that will become num1. Yeah.
So there's a num3 also.
No, not really,
Sir,
because
no,
as soon as we compare num1 and num2,
Right.
and
So
we take out the minimum.
The reason I'm sort of asking so many questions about this variable naming, yeah, because that explains the clarity of the algorithm in someone's head, yeah, in our own head, basically. If you can name something well, that means you're absolutely clear about it. Its function, its use, yeah. Then only can you name it, isn't it? When we don't understand its usage in a certain context, we always say name it anything, yeah, because you don't know what to name it as. You don't know uska function kya. You don't know what role is it playing within that scope, yeah. And when we are confused about that, we cannot come up with good names, right?
Right.
So we will name it min.
We can name it min. So can you explain me why should I name it min?
Because it will hold the minimum value at per iteration.
Absolutely. Yeah, see, the once you understand its function, you know, it's crystal clear in your head, it should be called min.
Yes,
because
sir.
it's going to hold the minimum value, isn't it?
Yes,
So
sir,
right now, you want to initialize it to the 0th element of the array,
Yes, sir.
right? But this minimum, this variable, when the algorithm finishes, at that point will be holding the minimum element of the array. And it holds the minimum. It holds the minimum up to the point that you have seen. So for example, I'm inspecting the 0th element. And when I'm looking at only at the 0th element, then this definitely is my min. So even at this point on line 14, I can say that statement is right because the only element that I've seen so far is the 0th one. And from that perspective, that is the minimum. So as I progress in the algorithm, as I progress through the array, this particular variable will be holding the minimum up to that point, right? And therefore, naming it as min is absolutely accurate. right? So you don't want to call it one num or whatever suggestions, were there. This naming business is something that you really have to pay attention to, when I'm interviewing, yeah, I'm looking at how they are
Hello,
naming
sir.
their, yes.
Sorry to interrupt. This is Prasanna. Sir, actually, I had little ambiguity. So
Yes.
the way you are explaining, it can be a min. It can be max also, because this is the first element I am referring, and so
Yes.
it can be max. So I think
Abs-
this referring it as a min does not make a sense unless we compare it or unless we can clarify it. So
Okay.
I think it must be a first element, and
Mhm.
we will take we will take the next element as a second element, and we will
Mhm.
compare the first with second, and the result of that, minimum of that, must be stored in this anti-mean variable. I
Right.
think.
Okay. So I'll ask you, Prasanna, that's thank you for adding that point of view. So I'm going to ask you this question. I'm going to create a temporary array here.
Yes, sir.
Okay. What is
Yes.
the minimum of this array?
One, sir.
So you do confirm that this is a minimum,
Yes.
right?
Yes.
This is a very special case where the minimum and the maximum are the same.
Yes.
So I'm still right when I say this is a minimum element. And you're
Yes, sir.
also right when you say this is a maximum element. It depends on what you're looking for
Yes.
in the further steps.
Okay, sir.
But at this point, that statement is still correct.
uh, yes, sir, you are right, but I think if anyone asks like minimum in the array, so there must
Yes.
be more than one element.
No,
I may be wrong.
no. So
Yes.
no. So the concept of minimum is not tied to the length of the array. I can give you an array with a single element and I can still ask you this question, what is the minimum in this array? And the answer would be the very element,
Okay, sir, clear, I got it.
right?
Yes, yes.
Okay. So
Thank
you're
you.
right that this can be the maximum also, and that is very correct. Yes. So if I was finding the maximum, I would have done exactly the same. I would have said int maximum as a function name, and I would have said int max equals array 0, and then also the statement would have been right. Right?
Yes, sir. Yes.
Okay.
Yes.
So
Thank
now
you, sir.
we try to inspect the further elements. Okay. So we write a for loop for that. Yes. Okay. Now can somebody help me here? So I'm really thankful to you. You're making this very interactive. So I'm really loving it now. Yeah.
Yes, sir.
For int I equals to 1
For int I
equals to 1,
equals 1,
I is
I is less than
arrays dot length
array dot length, let's say. Yeah. And
D
then
plus.
you increase this. Now a question, would it be wrong if I start with 0?
No, sir, it's not wrong.
No, sir.
No, right? But
Yes.
you can say that it's still, both are equally right to me. Obviously, you are being more smart here in the sense, you're avoiding that one comparison unnecessarily, because, you are going to eventually compare min with itself, sort of. Yeah. You're sort of saving on that one comparison, not much from a computer's hacking power, but that explains that, you do understand what you're doing. Yeah. So I have a few names here. This is how I can reference you with names. And what goes in here now?
One condition.
Yeah.
Compare.
Okay.
Loop, sir.
If is not a loop. A loop is something that sort of repeats itself. Yeah. If does not repeat itself. So if is a block. Right. So we say if. Okay. What should I compare? What's the condition?
Min with the current iteration, elements in iteration. index.
Right. So let's say if min is
Mean
less than or equal to
error of I.
array of I. Yep. Then what should I do?
Min is equal
Swap the sorry, no swapping. Change the value of min.
Yeah, so the condition is min is less than equal to. Is that correct?
Yes.
Then
sir.
I should swap?
No,
Yes.
sir. Hello.
No. Okay. So when should I swap then?
Min is greater than.
Min is greater than array of I.
Perfect. Yes. So then I say min equals array of I. Yeah. So I'm basically transferring the value of array I from min. So now imagine, I is at, let's say the array length is 100 and I is 5. After the 5th iteration, can we say that within the first 5 elements, right? If I look at only the first 5 elements, then min will be holding the proper minimum within those 5 elements. And that would be right, isn't it? Min would be holding the minimum value among those 5 elements if I have only done 5 iterations of this piece of code, right? So that min, the naming perfectly goes with its function within the scope. Yeah. And then when the whole iteration finishes, then what we have in the min is the minimum of the entire array. Yeah, and we return that. Now, have you done in Java also? You must be doing something like, do you test your code in Java?
Yes, sir.
And how do you do this?
So by running the program in a console. So like if we have ID, Eclipse IDs, and then we run program and see the output.
But how do you do automated testing? Do you do automated testing at all?
Not yet, yes. Sir.
Okay. So what I'm going to show is.
Are you using debug?
Yeah. So debug is not testing. Debug is debugging. So let's say I did something like this.
Unit testing, sir.
Yeah. So I did this and then I ran the algorithm. So let's say, how we are going to test this now. Okay. For example, one way of testing this would be that I call this from the main function. So instead of doing this hello world business, I call this minimum function. So, I say console dot write line, and I say minimum. I'm calling this function here, and I'm going to send in an array. So, we initialize our array to, let's say, -1, 2, 5, 10, 100. Yeah. And we run this. Okay. Yeah, we run this, control F5. And you see the minimum is coming out to be 100. And then you look at your input array and you say, clearly that's not the minimum. The minimum is -1. So then you want to debug. Yeah. So then you say, okay, let me put a breakpoint here and see what's happening. Okay. And then you inspect the value of minimum. It says min is -1 and array I is 1. And then if you want to inspect the value of array, then you say, okay, the 0th element is -1, the first one is 2. So you expect min to stay -1. Then you progress further, you go to the next step, and you see that you are going into this if, that means min is going to change. You say, oh, min became 2, which is clearly wrong. And then you realize, oh, I got the condition wrong. Right? So you then change it. This is debugging. Yes. And this is not automated testing. Right? So next time when I run this, it's going to run perfect. Yeah. So it's printing -1. Yeah. which is expected. So when what I meant by automated testing is, so this is a really simple algorithm, and maybe you can try a few inputs yourself and quickly realize that you've written the right thing. Yeah, but sometimes algorithms are complicated, right? So what we do is we create a unit test project for this. So let's say MS test. Let's create this. Call this algorithm tests. We add this to the same solution. Yeah, so what I've done is I basically created a unit test project for testing this algorithm. So what I'm doing is here, I'm demonstrating a principle. Obviously, it probably is an overkill for an algorithm that we just wrote, this minimum algorithm. But what I'm trying to demonstrate is a principle of test-driven development. How you develop your code using TDD style. So you write the tests and then you check your code and then you improve your code against those tests. Yeah. In this case, for example, let's quickly try to do something like assert, and we have to add, so we need to now refer to this project within this project. So we're building a dependency here. I say add project reference, and we add this. So we can start referring to this the algorithm that we wrote. We can now access it here. Yeah. So we say assert dot equal, and let's say we design an input where the minimum is -2, and we call our function. So our function is in the namespace, this namespace here. So we say using, yeah, and then we call our function. So our function is in the class algorithms. It's a static function, so I don't have to instantiate the object. Please interrupt if you're not following things that I'm saying. Yeah, so I would be more than happy to elaborate on them. Algorithms. Needs to be public. Dot minimum, and we provide our input here. So let me var test input equals new int. I create an array. Let's say 100, 10, 5, 4, -2, 99, 0. And we provide this as an input here. We call test input. Okay, so our test is now ready. We call it, give it an appropriate name, test minimum. And let's say we go and run this. And so we need to build this first.
Hello, sir.
Yes, yes.
So Vikas here.
Yeah.
So what is the meaning of that fact in the square brackets?
So when you are writing a test, basically what you're stating is a fact. Yeah. So your code must be evaluated against that fact. Yeah. So we have this concept of TDD where we call it the test-driven development. Yeah. So the idea is that when you are writing a piece of code, you're writing. There has to be a motivation for me to write that piece of code, and that motivation comes from a breaking test. Yeah. So this is if you're strictly following the test-driven development methodology, then what it means is I'll write a code only when I have a failing test. Yeah. So a test is a specification of how your program should work. So for example, if you look here, let's say I could have written this test without any of this existing, without actually writing that minimum function. Yeah, I could have written this test. I could have stated that this is a fact, and this fact should be green ticked. Yeah. So when I run this test, and let's say I haven't written a piece of code, then this fact fails. Yeah, because there is no algorithms or minimum function. So now there's a motivation for the developer to actually write that function. Yeah. Yes. And if you think from a, so, you know, there's an idea of use cases. Yeah. So when we are developing a very complicated, a very complex or big project, you know, the idea is that, you know, your piece of work is coming from business requirements. And we're saying those business requirements are captured in the TDD methodology. Those requirements are captured as part of failing tests, which means that if this test passes, then you have done what was expected. Because there's always a difference between the customer specifying something, then the business analyst understanding it, then explaining it to the developer, and eventually the implementation. And there's always a huge gap between what the customer really wanted and what the developer ends up delivering. Yeah, and this gap is because the specifications are not very clear. One of the ways where you can really engage your customers in the TDD style is where you write these facts, and these facts are written in a way, so apart from, you know, the name, for example, the sort of inputs that go, the way the test is set up, these are all done from a business language point of view. Yeah? So you create your functions, your objects, everything in a way that someone, even from, you know, the stakeholders can understand what you've written, you know, and they can verify the specification that this is exactly what they meant and this is what you're supposed to be delivering. And then the developer is writing code against that test. And if he makes it pass, then basically you've delivered what was expected, right? So that's the reason why you call it a fact, because this is a fact from your perspective. Yeah.
Okay, got it.
Let's run this. Yeah, I'm hoping it passes. Yeah, cool. So now what's the idea of this? You know, so imagine that you're writing a program which is, let's say, involving many functions and is over 500 lines of code, right? And there are lots of conditions and branches and some complicated piece of maths and stuff like that, and you want to test that entire thing, right? So the idea is that, you know, you cannot test it with that whole debug methodology. So I cannot sit there and, you know, sometimes even providing the inputs is a complicated business, yeah? Or framing the test in that function way, you know, the way we did here, for example, is a very complicated business, right? And therefore you have this idea of testing, of automated tests or unit tests, where it's very clear that there is a specification that is always present, and every time you make a change, then your change is evaluated against the initial specification, which you call as fact. Yeah. So which means when you are changing, you know, you're always sort of secured in a sense that, you know, I will not be breaking the functionality of this piece of code because I have tests which will automatically test whether what I've done is right or not. Yeah. For example, there was an algorithm which was rightly implemented, but what taking was of order n square. Yeah, we'll come to order. Right. And then you realize, okay, this is causing a lot of pain to my customers because they have to endlessly stare at the web page. Yeah. So I want to make it fast, which means you want to, let's say you come up with this brilliant idea and you say, you know, I have a way of turning this into an n log n. So, you know, I'm going to make it subquadratic. Yeah. And you start implementing that. Now, how do you ensure that, you know, the changes that you're making are really leaves the final code that you come up with is really working? You know, you can maybe try one or two examples and it all works fine. Yeah. But how do you really guarantee that this piece of code is doing exactly the same as a previous piece of code? And therefore you write a bunch of tests depending on how complicated or how elaborate your eventual algorithm is. You may have 10 to 20 to 500 tests. Yeah. And when those tests are running, then there is a good confidence within you that, okay, whatever I have done is not breaking the existing functionality. And therefore the necessity to have unit tests in your code. Yeah, so testing is very much part of your development. Yeah. Now I sort of touched on this thing called order. I would like to understand, how many of you understand orders of, runtime order? It's the order of an algorithm. So what is the order of this algorithm that we've written? Is it quadratic? Is it n log n? Is it linear? What is it?
So linear.
This is linear. And what does that exactly mean, linear?
Linear means starting from the first index and then iterating over each index and reaching at the last index.
Okay, so let's say if for some reason, my algorithm only needs to iterate half the length, is it still linear?
No, it's not.
Or this will become linear by 2?
So it's a binary. If we use linear by 2, like take first and second, first and last and divide by 2, so it become binary.
Okay, so now we change topics. We were discussing the runtime of an algorithm.
I'm sorry.
Right.
Sorry.
So binary is completely different. Yeah?
Yes,
it's an algorithm in itself. It's not runtime.
Yes,
yeah?
sir. Exactly.
So the question is, I think it was Vikas probably. You said a linear algorithm is one which starts from the start of the array and goes to the end of the array. Yes. And my question is, if I'm not going to the end of the array, let's say I'm only visiting half the array, is it still linear in nature?
Yes, sir, it will be linear.
So redefine what linear means then, because you said till the end of the array.
Okay, so linear, so redefine
Yeah, so that cannot be the definition of linear, isn't it? Because you said it starts from the first element and goes to the last. And now I'm saying that I only want to go till half the array. So is it still linear? And you say, yes, it is still linear. That means the previous definition is not right. Right?
Hello.
Yes.
Sorry, sir, I got disconnected. Actually, my Wi-Fi went power off. Sorry.
Okay, so I'll repeat myself. Is that you, Vikas?
Yes, sir.
Okay, so Vikas, you said when I asked you to define linear, you said if the iteration starts from the first element and goes till the very last element, then we call it a linear algorithm, right? Did I get you
right? But I redefine it like in a sequential way, one after one, like.
Okay.
Yes.
So let's say my algorithm skips the next element. So it always sort of goes, skips the next one and skips the consecutive one and takes the alternate ones. Is it still linear?
Yes, sir. It is still
linear. So
linear.
we need to redefine it.
Yes, sir.
Yeah. So yes, right. So I'll try and answer that. Yeah. So linear has got nothing to do with how you are iterating or how it has got to do with how many elements you're iterating. I'll come to that point, but it's got nothing to do with how you're iterating. One. By linear, what you mean is when you're looking at the overall time that this algorithm is going to take, yeah, then you're defining it that it's a constant multiplication of the number of elements in the array. And that constant keeps changing. Yeah. So for example, I would say the runtime of this algorithm. Come on. Runtime. That's not nice. I should start a comment. Yes. Runtime of minimum in some maths terms, it is k times n. Yeah, and what is n? N is the number of elements in the array, and k is a constant, which means if you look at this graph, it's going to be a straight line with varied slope. As k changes, the slope would keep changing. So if I can draw something very quickly. Concept code. Come on. Okay, let's see. Okay, I need some. So if we were to so linear algorithms runtime looks like this. The slope of the line can keep changing depending on that k, but it's always a straight line. Yeah, and this axis is n. Yeah, number of elements, and this axis is runtime, time to run the algorithms, right? Okay, so as the number of elements increases, you see that, you know, if you sort of scale your imagination, this line is infinite, and as the number of elements increases, the corresponding time also increases. So if you're here, then the amount of time it takes is this much. Yeah, if you're here, the number of elements is, let's say, 4, the amount of time taken is this. But what I'm trying to define, so this number is not important. What I'm trying to highlight here is the fact that it's a straight line. Yes. So no matter how much the number of elements increases, it's always going to be a straight line. Yeah. And the slope of this line is basically this constant value k. Yeah, that defines the slope of this line. And we typically don't write this because it's not important. We always write something like this. So we say, yeah, it's order n. What does that mean? It means as the number of elements increases, the runtime increases proportionally. Okay. So if I took 10 seconds for 100 elements, I will take 20 seconds for 200 elements. That's what linear means. The runtime scales proportionally with respect to the number of elements. That's what proportionality means. Sorry, that's what linear means. Yeah. For example, if I look at an n-squared algorithm, yeah, then an n-squared algorithm's graph is not going to look like a straight line. It's rather going to look like, now it's difficult to draw here, freehand. Okay, I'll try my best. Shapes. Nope. नहीं चाहिए. Freehand करते हैं. Let's see क्या होता है. So a quadratic algorithm would go something like this. Yes, this is what a quadratic algorithm would look like. Again, here the shapes, you know, the slope of this can vary. So, you know, some of them might be even quicker, some might be a bit slower. So some might be like that. Basically, it's a parabolic shape. Yeah, if you remember your 12th standard, it's a parabolic shape. Yeah. So now here, look at this, you know, very interesting thing. So when the number is small, the overall time taken is less. But you see, as the number of elements increases, the amount of time taken rises at a quadratic speed. Yeah. You see, for, you know, if that means if I'm taking 10 seconds for 100 elements, and if you double that, it's not going to be 20 anymore. It's going to be 100 seconds. It's scaling very fast. It's not scaling at the same rate. It's not proportional anymore. There's no linear relationship. There's an quadratic relationship. And there are exponential algorithms, where this is n raised to n, and those are crazy. Yeah. We never run those. Those would look something like this. Yeah. So, so that's what runtime means. I am hoping that you got something out of this. Yeah, so is there any question over this runtime of algorithms? You realize that it's got nothing to do with how and how many elements you're looking. So, even if I'm looking half the element, the proportionality, just the slope changes. Yeah, so Akash, you were saying you have to see all the elements. That's not necessary. If I'm, let's say, when I look at all the elements, let's say the graph looks like this. When I look at half the elements, the graph would probably, I need to change. The graph would color. The graph would probably look like this, but you see both are still straight line graphs. So me changing here from array.length to array.length by 2 only changes that constant, that slope. Yeah, but the graph is still straight line. Yeah, or whether I keep it like this and I say I'll skip the next element and I will go I skip the very next element and take the alternate ones. It's just the slope of the line changes, but it's still a linear algorithm. Yeah. Is there any question over this? Please do let me know. I'll be more than happy to explain. 357. I'm not looking at the latest chat. Okay, perfect. Okay, so now we are going to go to, so it's n. Where is my, yeah. Okay, so we're done with problem 1. Now we are going to make it a bit harder. Yes.
Sir, please go to the Visual Code unit test.
Sorry, can you please repeat yourself?
Sir, please go to the unit test slide, Visual Code slide.
I can't really get you.
Sir, please explain line number 13 in Visual Code in unit test code.
Line number 13 in test project.
Yes, sir, unit code. Sir, what is the means of assert equal?
Sorry, I completely skipped over that. Thanks for reminding. So what am I saying? So I'm saying, you should assert, so assert is like, you should verify that these two things are equal, So when I say assert.equal -2, this is my expected output from what I'm going to do here. So I'm expecting -2 to come back, and then I'm giving the actual value. So the actual value I get is by calling this algorithm and providing this test input. So I'm actually designing my test, and I'm saying for this input, I should get -2. So you see here, written expected, yeah, and actual. So let's say we make a small change again in our code, and we actually make it fail this time. Okay. And we run this test again. So this time it should tell me that, hey, your expected value was -2, but what I really got back is something else. You see, so it says assert.equal failure. That means this equal condition, this equal function did not pass. Yeah.
But just like use cases, na?
Just like what?
Use cases, na?
Use cases. Are you asking just like use cases?
Yes, sir.
Yes, absolutely. So, I'll be stating a fact, I'll be designing my inputs here, and then I'll be executing. So when you're thinking of a test, there are 3 phases. Yeah. So the first phase is designing, and we call it the test setup. And what does that involve? It involves instantiating needed objects, yeah, from your needed objects. Then create designing your test input. Okay, that's the first phase. Yeah, test setup, the first phase. So this is what basically I've done here. Okay, this is what I've done. In this case, I did not have to really instantiate an object, this is a really static function. So there is no need for me to really instantiate any object. I can directly call the function. Yeah? So that's why there's no instantiation done. But I've clearly designed my test input. Yeah. The second part would be where you execute the system under test. So what I wanted to say here is needed objects from the system under test. Yes. Or from the proper thing would be from your application. Okay. And now we execute the system under test. So in this case, what I'm actually executing is this is my system under test. Okay. So I can say var result equals algorithm.minimum. Yeah. And then the final phase is asserting your result. Okay, asserting the result. So we take, so in this case, I know, we also say var expected input, expected output equals -2. Then I go and say my expected output should match my result. Okay. So there are 3 parts to a test. You instantiate objects from your application which are required to, let's say, set up the test. You design your test input, then you execute the system under test, the very thing that you want to check. And then eventually you take that result. You already know what the expected output must be because you designed the test input, so you know what the output must be. Yeah. And then you're asserting whether the input and the outputs match or not. Yes. And let's say now it fails. So you go back and you correct it. Yes. And we run this again, and this time it should pass. Yes, I'm hoping I answered your question.
Yes, sir, got it.
Yes?
Yes, sir, got it.
Perfect. Okay, so we can, actual is 4 and expected is -2. What did I do? Sorry. We did this also, right? See, this is how the tests always make sure that you get the right thing.
Yes, sir.
Yeah, there's a live example. I would have probably checked this code in, and then all over the world things would have broken down.
Yes, sir.
And now it passes. This is how the test always makes sure, because we had designed the test, right, and we ran it. It made sure that that mistake, which while I was describing this whole order business runtime, I had made this change, and I completely forgot about it. But the test didn't. Yeah, this is why you need tests in place.
But if I want to work on big projects, so it is very helpful for us. Like to do unit test now. It is very helpful when I want to work on big project.
Yes, Yes, it's very necessary. That's right.
Very helpful for us.
Yeah, in fact, there are there are concepts called gated check-in. So where, for example, I would not allow you to check in your code unless there is a certain percentage coverage of tests. So for example, the test will tell you whether there's a 100% coverage, whether there's 90% coverage. So they basically tell me how many tests are, what is the part of the code that is covered with tests. That means that using those tests, you do touch those lines of your code. So there are these metrics, and we sometimes have this gated check-in where we do not allow a code to get in onto the master branch unless there is a certain percentage of coverage from the tests. Yeah. So
Yes.
sometimes organizations are absolutely strict about this. They cannot have, because we're talking of what 10 lines of code here, and even then while talking I made this change, and this bug could have crept in. Imagine when we're working on projects which are millions lines of code, there are 30 developers, and it's been worked upon since last 30 years, right? How do you maintain such a code if you don't have tests in place? Somebody can make some change and you don't even know when it's going to break and for what it's going to break. Yeah. So from day one, when you're writing this test, today you start with one test, and then the code grows, and then there are 5 tests, and the code grows, and there are 10 tests, and so on and so on and so on. When it's million lines of code, you probably have 2000 tests. And that is what gives you confidence when you're making changes in your source code. Yeah.
And so that's where versioning system comes in.
Yeah, the versioning system has got nothing to do with the correctness of the code. Yeah? The versioning system, you can write absolute crap in there. Yeah. So for example, versioning system would not have any problem if I go and make this code check-in today.
Yes,
the versioning system would very happily accept it, right? So the versioning system is there to keep track of your code. For example, I want to see now कि ये I plus equals to किसने किया, क्यों किया, कौन से requirement के against किया, reviewer कौन था, किसने approve किया, right? So when I want to do the root cause analysis, then I want to go and find out कि okay, ये bug कहाँ से आया?
Yes.
Why did this get in the first place? Who was the what sort of a review process was done? Who was the reviewer, right? That's one part. The main part is management of your code. So if you have, let's say, 15 developers on the project, and when you have you have the concept of a sprint where, for example, within the next 2 weeks, we decide that yes, versioning system can be used for that also, to roll back to the previous code. So so when we decide on a number of user stories, so we say, okay, in this 2 weeks, we are going to implement 5 new features and we're going to solve some bugs, right? Then you have a team of 15 and you distribute this work among yourselves. Then everyone can independently start working on their stories, on their features. So for example, I'll create 5 feature branches, and then I can start independently working on them, which basically means that, I'm not dependent on someone. I can carry out my own piece of work on my own branch without disturbing any of the work that others are doing. So it really helps in day-to-day development, and then you have ideas of committing to local repo and then pushing it so that you can distribute it. You can do distributed development. So, the versioning system is a completely different ball game for a very different reason.
Yes, sir. Got it.
So I'm sorry, I'm going a bit fast over some of the things because I'm not sure we have all the time to cover everything. It's already 5:11, I sense. So Keshav, was this session only for an hour? Is Keshav there?
So according to schedule, it was up to 5:30.
Okay, that's fine. We still have about 20 minutes. Yeah. Okay, so let's quickly look at this now. This example, sorry, not example, the problem 2. This is given an array of distinct integers. Determine the minimum absolute difference between any 2 elements. Print all elements pair with that minimum absolute difference in ascending order. I'd like everyone to read this and take a moment of pause and try to grasp what the problem is asking you to do. So you are given an array of distinct integers, which means none of the elements in the array would repeat itself. Yeah. It says determine the minimum absolute difference between any two elements. Okay. So do you understand what is meant by minimum absolute difference? Can someone answer me? I'll call out some names. I have names on my mobile. Mansi, is Mansi in here? Oh, she's hiding. How about Pratik? Two Pratiks, Pratik Agrawal. Is there Pratik here?
Yes, sir. Yes, sir.
Hey, Pratik.
Yes, sir.
So can you tell me what is meant by minimum absolute difference? Okay, let's first say what is absolute difference between any two elements.
Different between two numbers, just like difference between 2 and 4, 2, 6 and 4, 2.
Right.
This is the requirement.
So, yeah, so let's try to see all the pairs that we can generate from these. Yeah. So can somebody tell me how many pairs we will generate?
3 pairs.
How many pairs?
3 pairs, which gives me difference of between two elements is 2.
Sorry, can you tell me? I can't hear you very well. Can you tell me how many pairs that you can generate? 4 pairs. Akshay says 4 pairs.
Sir, but requirement is that the difference between two elements is 2.
We're not talking of the minimum right now. So my question is a bit more simpler. I'm saying how many pairs you can generate. So there are, Vikas is saying 6, Nilesh is saying 6, Barkha is saying 6. They are all right. Yeah. So the number of pairs that I can generate is 4C2. Yeah. Don't do that with us. Don't take us back to 12th standard or 11th. I don't know when was this. Right. So 4C2, what I mean by that is you're choosing 2 out of 4. Yeah. So for example, these are the possible pairs: 6, 2, then 6, 4. How many of you have seen this movie, Hrithik Roshan ka movie? What is that? He's a sir in that, teaches IIT kids.
Super 30.
Super 30, yes. How many? You've seen that movie?
Yes, sir.
Usme, you know, there's a dialogue, there's a sequence where he says to his kids, if there is a room of 15 people and 30 people, I think, or some number, and he says everyone shakes hands with everyone else. What are the total number of handshakes? You know this? Okay, forget it. So, yes, NC2.
30C2.
30C2, that's right. Are you sure 30C2 is the answer?
30C2 minus 1.
Minus 1, interesting.
Yeah.
Okay. So you see, when you do 30C2, you're choosing 2 out of, so you're basically making combinations of 2 people. So that is the answer, 30C2. There's no minus 1. So 6, 2, 6, 4, 6, 10, then 2, 4. So who was that with 30C2? Can you please tell me your name? Barkha, okay, great. Right, so you see 6 pairs there? No, 5 ho gaya. 6, 2, 6, 4, 6, 10, 2, 4, 2, 2, 10 missed. 4, 10. Yes. So, these are the possible combinations. Now let's try to write the absolute difference of these pairs. Yeah. So what would be the absolute difference of 6 and 2? Yeah, thanks, Aishwarya, Mahesh. It's 4. Yeah, it is not minus 4. Yeah, see, it's the absolute difference. So it's always the higher value number take away the smaller value number. Yeah. And then 6, 4 is going to be 2. Perfect. 6, 10, it's going to be -4. There's someone agreeing with me, Snehal. No, it's not going to be -4. Like I just said, an absolute difference can never be negative. Yeah. So 4, 2, 4, 2 again, 2, 10, 8, and 4, 10, 6. Perfect. Right now, we want to look at the minimum absolute difference. Yeah. So the minimum absolute difference out of this is 4, 2, 4, 2, 8, 6. Iska matlab 2 is the minimum absolute difference, right? So the minimum is 2. Everyone agrees with me? Perfect. And now we want to find the pairs that have this as the difference. Yeah. So we start, let's say here again. So we say 6, 2. Uska difference kitna hai? 4 hai, 9. 6, 4 ka difference kitna hai? 2 hai. Yes, that matches to the minimum pair. So I will print 6, 4. And then I say 6, 10, 4. Again, I reject that. 2, 4. Yes, the minimum difference is 2. Right? And then 2, 10, difference is 8, 4, 10, difference is 6. So I reject all those. Yeah. And now the last condition of the problem statement, which says print all element pairs with that minimum absolute difference in ascending order. So I cannot print it 6, 4, and 2, 4. You know, the way I need to print that is 2, 4,
6, 4,
and 4, 6.
okay.
Yeah. So this is the final outcome that is expected from this algorithm. Is everyone clear with the problem statement? Okay, great. Thank you for your confirmation. And let's go where we get our hands dirty now. Yes, that's the fun part. Okay, so we need to create, okay, we can write a function here itself, or we can create another file. Okay. Add new item.
5 बजे नहीं आई हूँ, 4 बजे आई हूँ। मैं 4 बजे आई हूँ। हाँ।
Okay, someone might want to mute themselves. Okay, so what's the name? Yeah, let's call it minimum absolute difference, right? No content page class. That's what we want. Okay, it's created this class, and let's say, okay, now interestingly, I want to understand what is the function signature here. We got to speed this up a bit. Yeah. Is it okay, if this session extends a bit over 5:30, would that be okay with everyone, or you have some real engagements after this? Okay, so I would say, for people, for those for whom this is okay, they can stay back. For people who have some engagements after this, please feel free to leave the room. Yeah. Okay, so please help me with the function signature. Bearing in mind that I want to test this function later. I want to sort of go back to that minimum function. I want to see, sometimes when I'm interviewing a candidate, I'm saying, write me a function that can be tested. And they don't understand that. And then what they tell me is, because maybe this is what they've seen the teachers doing or whatever, I don't know why, but everyone ends up writing. So I'm going to change this piece of code now quickly and show what they end up writing. They write this. They always start with a void function for some reason. Yeah. And then they never return. And then they say console dot write line, something like min equals minimum. Sorry, min equals min. Okay. And then I tell them, but I want to test this function, how am I going to test it? Then they say, sir, run this function, console pe ye minimum print karega. And I'm like, I'm not going to be there all the time looking at the console in my life. That's not my only job. My job is to do a lot of things, right? So, so I want to be able to automatically test this. And, they don't understand. They think I'm crazy, sort of, Now, yes, absolutely. So when we need to automate testing, this function will not survive that, because this function never returns me anything. To me, such functions are like black holes. Uske andar jata hai, bahar kuch nahi aata hai. It's like, you send input in, nothing coming out. It's like absorbs everything in. Yes. And these functions are not testable. When you don't return back anything, there's no way to test it. It's like, I hate this thing. When somebody writes me a function which is void, I absolutely hate it. And then they are printing on console, and it's not their fault by any chance. I think this is how they've been taught. Maybe everyone is, because for the sake of brevity, it's always maybe that's how things are shown to them. That console.writeline. This is what gets embedded into their head. You can always do console.writeline here from where you're calling that function. So for example, I did do control.writeline, but when I wrote the function, it was not a black hole. It took an input, it gave an output. So I can test this function. I can call it from here, and I can also call it from the unit test, right? So I can call it from anywhere I like, and that function is, is always usable. Imagine this, that you're writing a different project and you want to use my absolutely amazing minimum algorithm. So you say, okay, Kapil, give me your library, a jar file, just apni minimum implement kiya hai, I really want to use this. This is going to make my project success. And I give you that, and then you call my function and you say, take this set of inputs, and nothing comes back to you. How do you feel about that? It's trying to find a console somewhere and print onto it. There's no console, let's say. It's a UI application, right? Such function is not even usable. So for example, library functions would never be like that. You'll always see that library functions would return you a value back. So this is an absolute must, that don't write void functions. Void is like black hole. Avoid black holes. And avoid printing within the function itself. Now going back here, tell me, how would you write the signature for this function? Anyone? Do I need to call names? Is Rahul there? Malhari? I'm pretty sure they are there.
Hello, sir.
Yes.
So Mahesh here.
Yes, Mahesh, please tell me.
So I think the return type will be int.
Int, okay. So let's call it public int, okay. And Mahesh, why do you think it's int? What are you going to return? So imagine going back to this example which we were looking at. This is
because
what.
So because we are returning an integer, that's why the return type will be int.
But why do you think you will be returning an integer?
So because
see, this is what I want to return, isn't it?
Yes, sir.
So is this an integer?
So it is a pair of integers.
Yes, you're going great. But is it just a pair of integer? There's a pair of integer would be something like this. I'm going to modify this a bit.
It's a list of pair of integers.
Yes, absolutely. It's a list of pair of integers, or you can call it tuple if you heard this name before. So it is not an int that I'm returning. I'm returning a list
of integers.
Of pair of integers. A pair is also called tuple. Okay. So this is what I'm returning. A tuple which is of type integer. So a tuple can be integer, string, whatever. So in this case,
but tuple like key value pair, kya?
No, it's not a key pair. I mean, you can attach any semantic to you that you like, but typically that's not the semantic that you attach to it. Yeah. So a tuple is, for example, where I don't want to, it's sort of an anonymous class in a way. Yeah.
Okay.
Where I don't want to. So for example, for the same thing, I could have created another struct. For example, I could have called pair of ints or something. And I could have said int first number and int second number. Yeah. But this would have been very elaborate on my part because I have to create a new class, sort of give it a generic name and all that. Instead of that, C# provides me a way where I can sort of create structures on the fly. It's like a dynamic definition of a structure. So I'm basically a pair with two integers. Yeah, that's a very sort of a general requirement, isn't it? So we have something in the language itself where you can create a tuple of whatever types you want. In this case, obviously, we're creating a tuple, like you said, pair of integers. Yeah, so these are integers. Okay, so in this case, it's going to be a tuple of int. Imagine this is pair, basically. So imagine I'm writing pair here instead of tuple. Yeah, but the idea is not that one of them is a key and the other one is a value. You can obviously attach any semantic that you want with it. But for example, take the scenario. There's no key, there's no value here. And now let's try to come up with an algorithm. How are we going to solve this? Yes. So we can look at the steps that we've done. So what is that we've done here? So what we did is we tried finding the absolute difference between all the pairs, right? Yes. And then we tried finding the minimum from that. And then we got these, then we went back into this pairs list, and then we found the pairs that were, let's say, matching with the minimum. Okay, and then we wanted to return, but before returning, we sort of sorted this in some sense, isn't it? Right? So we need to sort this, yeah? Sort the output. And it's not a simple sorting, isn't it? So it's sorting, obviously, it's not sorting like, these are not like phone numbers and we're sorting them. We're sorting pairs. Yeah. So we're saying 6-4 should become 4-6, 2-4 remains 2-4, but 2-4 should precede 4-6. Yes. Sneeze. Right. So can somebody tell me what's the runtime of this algorithm?
Hello, sir.
Yes, Mahesh.
Sir, I think the order of n, sir.
Okay, order of n. So why do you say it's order of n?
So because, sir, it will evaluate till the last element, sir, and it will check the minimum differences between all the elements. So I think it will be order of n.
Basically, you're making me feel like hit myself punches now.
No, sir.
Yeah, why? Because I thought I explained. So I clearly did not do a good job there. Oh, it's very sunny. Yeah, better. So we go back to this, right? And when I said something is linear, if this graph looks like a straight line, that means the runtime of the algorithm depends linearly on the number of elements, which means it's of fixed proportion. It increases or decreases in a fixed proportion, in a constant ratio. Whereas a quadratic algorithm looks something like this, where the runtime is scaling in a quadratic fashion. So for example, if the number of elements is 10, and let's say the time taken is 20, then when I become from 10 elements to 20 elements, then the time will become from 20 to 20 square, that is 400. Yeah, it's not going to be 40 anymore. Yes. And I said that it's got nothing to do with last element or first element or traversing all the elements or half the elements or skipping in between elements. It's got nothing to do with that. What you're looking at is whether the algorithm scales linearly or not, right? Now let's look at what we worked out here. So what did we work out? We said, okay, there were 4 elements, yeah, right? And from this 4 elements, how many pairs did we create? We created 4C2 pairs, yeah. So if there are n elements, how many pairs would we create? So the answer would be NC2. And you know what's the formula of NC2? It's n times n minus 1, the whole thing divided by 2. Now, frankly speaking, this divide by 2 from a runtime does not matter because it's a constant factor. Yeah. So this, if I simplify further, I get n times n minus n times 1. So n times n minus n times 1, which is nothing but n raised to किधर है? I got specs and I'm not wearing them. Raised to 2. Thank you. Much better. So n raised to 2 minus n, yeah. And again, from an order perspective, the takeaway n also does not matter, yeah, because that does not change the eventual shape of this graph. So this graph again, ये shape change नहीं होता है, इसका सिर्फ starting point change होता है with you subtracting something like n from it. Yes. So where are we? Yes, here. So n, which is n raised to 2. So its order is n square. Now these are the total number of elements that you're going to generate, and then you are going to go over those elements. So your new element set becomes this, and you're going to go over these elements, you're going to find their differences, and then further on you're going to do processing, which means if you look purely from how many for loops you will end up writing, you're going to write 2 for loops, isn't it? In order to generate these kind of pairs, you would have one for loop which goes from 6 to 10, and then the other for loop which follows from the next element to the last. Yeah. So for example, you know, if we quickly want to just generate and see those pairs for ourselves. So let's say int I equals 0, I less than array dot length minus 1, I plus plus, let's say for int j equals 1, sorry, j equals I plus 1, because we want to start from the next element where I is. We say j less than array dot length j plus plus. Okay, I'll explain this in a bit. Yeah. And let's say this time I just want to quickly see what am I generating. Yeah, so I'm going to do a console.writeLine here, and we're going to write down the pairs. Yeah, so we're going to say order, and we want to write this pairs like this. We say array of I, array of j. Come on. Okay, that seems right. Nice. comma array j. Oh, sorry. No. Oh, yes. Okay. So let's run this and let's return null so that it starts compiling. Okay. Okay, it's never used. Sure. Return from here. Okay, and let's call this function now from the main program. We're not going to call minimum anymore, but we're going to call what's this? Minimum absolute difference. We give the same namespace to it, and we call minimum, for some reason, yes, public. Let's make it static so that we don't have to instantiate the object. Still some problem. Minimum, oh, sorry, it's called minimum min absolute difference. Just bear with me for some time. Okay, and we give this input 6, 2, 4, 10. Probably 10 more minutes. So now we have this. Still a problem. It does not exist in the current context. Let's build it. It's not combining because it does not exist. Public static class. Okay, let's not waste time on this. Let's copy this for a moment here so that it starts working. We need to use system load collection generic. Yeah, there's a missing semicolon. Okay. So we can let this be, yeah. Okay, so let's try to run this now. Let's see what comes out. Okay, so it's 6.2, 6.4, 6.10. Then 2.4, 2.10, and 4.10. Yeah, this is exactly what we wrote here. Right, 6.2, 6.4, 6.10, 2.4, 2.10, and 4.10. Right. So basically, did everyone understand that code, or do I need to go over it? You know, in interest of time, I would do this only if you guys want me to do that. So please let me know. Right, everyone is saying understood. All right, so I don't need to go. So just sort of stressing this point, you know, that there's an n squared algorithm. The reason being, you see that we are iterating over that list in a nested fashion. Yeah, so we have an outer loop which is going from 0 to array length -1. So again, from a runtime perspective, that's n iterations. You don't have to be specific that sorry, go n-1. From a runtime perspective, it is n. Yeah, it's order n. Like I said, n by 2 and n, it's same order. Yeah. And then within that loop, for each of those iterations, I'm sort of reiterating the array again, this time starting from I plus 1. Yeah. And again, from a runtime perspective, as we have understood, next index of to last index, absolutely, yes. But when I say from a runtime perspective, it's again linear in nature when it comes to the number of inputs, right? So I have an outer loop which is linear, and I have an inner loop which is again linear. Yeah. And therefore, because it's nested, right, the runtime is linear times linear, which is quadratic. Yeah. So therefore, the runtime of this algorithm would be quadratic. Now, what I quickly want to do is, because in the interest of time, I want to do a more optimized algorithm. I would have ideally shown, we would have written this code, we would have taken some big inputs, and we would have seen that, it takes time to actually come to a solution. And therefore, we should improve this solution that we have come up with here. And this we would have done by writing some tests, making sure that our brute force algorithm, so I call this the brute force approach, yeah, and this is working. We have tests that are passing, and then we would have went on to improve that efficiency of that algorithm. Now I'm sort of skipping those steps, and we will directly jump to writing the optimized version of this algorithm. So I want to think on these lines. You see that eventually you do want the sorted output, and interestingly, you see that you're going to take the pairs, you're going to take the minimum absolute difference. Yeah, can someone think? Can you guys think that if you want to take the minimum absolute difference, yeah, then maybe you don't need to evaluate all the differences. Yeah, so imagine that if you have an input of 10. So agar n is 10, then how many pairs we would be generating? We'll be generating 10 times 9 divided by 2, so 45 pairs. And if n becomes 1000, then this is 500 times 501. Yeah, so it's a huge number, 500 times 501. Yeah, that's a huge number, right? So can you think, because we are doing a lot of necessary evaluations, we're generating a lot of pairs which would never make, for example, 410. There is no chance that 410 would make it to the final list. It will never be in the output. I can look at it and say, why? Because I see there's 6 in between. So 410, the absolute difference will always be more than 610, isn't it? Do you guys agree with me? Please, some confirmations. Thanks, Prasanna. है ना? So अभी इसमें देखो, you, for example, evaluating 210 makes no sense because I know 2 के बीच में 4 है, फिर 6 है, फिर 10 है. अगर 2 और 10 का absolute difference minimum हो ही नहीं सकता. There's no chance for 2 and 10 to have an absolute minimum difference because I know there are numbers in between. So at best it can be 2-4, but it will never be 210, right? So now do you get some hint as to how we can reduce the total number of pairs that we generate? Yeah, so now I'm going to, just do a little change in this. Let's say what we do is, you gave me the input 6, 2, 4, 10, and I convert that into this input. Yeah, 2, 4, 6, 10. Any hints? You see where am I going with this? Now, which pairs would you evaluate? Tell me. Would you evaluate 2, 4, 2, 6, 2, 10, 4, 6, 4, 10, and 6, 10? Or you would evaluate a lesser number of pairs? Yeah, so we've sorted. That's clear. Yeah, Prasanna? Yes, we will only look at the successive elements, isn't it? Because it makes no sense to look at 2, 4 and then to look at 2, 6. Right? So I'm only going to look at perfect Vikas, that's right. 2, 4. Then I'm going to look at 4, 6. And then I'm going to look at 6, 10. Right? So I'm only going to look at 3 pairs. Now, if there are 500 elements, sorry, there are 1000 elements, how many pairs do you think we'll be looking at? Any ideas? If there are perfect, it's 999. You see, we have made it, yes, it is n-1, right? So now what is the runtime of this algorithm? If you're only looking at n-1 pairs, what is the runtime of this algorithm? Is it linear? Hello? It is linear. No, Vikas says no. Why, Vikas? Why do you think Vikas it's not linear?
Sorry, sir, it will be linear.
It will be, isn't it? Because
Yes,
we said we'll only look at n-1 pairs.
Yes,
So from a runtime perspective, n pairs. Yes?
Yes.
So it's linear in nature. Yeah. Obviously, there's a catch there because I very nicely wrote this thing. This is called sorting, as someone pointed it out there. And what kind of sorting algorithms have you come across before? Binary? Have you come across binary sort? I see a lot of people saying yes. It would be very interesting to me if you explain me what a binary sort is. Bubble sort, yes, bubble. But is there something called binary sort? No, there is a binary search. एक आम है और एक apple है. Huh? They're not same, right? Searching is different than sorting. Yeah. So there's nothing called as binary sort. Yeah. There is definitely something called as bubble sort. Okay. What's the runtime of bubble sort? Anyone? If you vaguely remember what you do in bubble sort, n square, isn't it? Yeah, because you write 2 for loops. Yeah. So what is the overall runtime of this algorithm then? It will still be n square, isn't it? Right, because there is the most of the time will be spent in the sorting part. Yeah. So then it sort of feels like we haven't gained much there. Yeah. We converted one style to another, it's still all n squared. The reason is we are using bubble sort. Yeah, there are much better sorting algorithms than bubble sort. So there is something called as merge sort. There's something called as quick sort. Have you heard about quick sort? Yes. What's the runtime of quick sort? So bubble sort is order. Bubble sort is order n square. Merge sort is order log n. You know, Mahesh, if you can come with a sorting algorithm which is log n, you would be a billionaire.
No, sir, I missed the end, sir. Sorry for that.
No, you don't have to be sorry. I'm just kidding. But you surely be a billionaire if you come up with a log n algorithm for sorting. Okay, so yes, divide and conquer, that's great. So you know, both merge sort and quick sort of work on those principles, divide and conquer type of strategy. Yeah, they sort of break the inputs into smaller inputs and then work on those small inputs, and this is sort of recursive in nature. So you know, let's say you have a array of size 20, then you break that into 10, 10, and then you say, okay, I'm going to sort this 10 and this 10, and then I'll merge. Yeah. And then you take those 10 and you break that further into 5, 5. Then you say, I'm going to sort this 5, and then I'm going to merge. Then you go further down, and this is how merge sort works. Yeah. A quick sort of works on the same principle. Again, you try to find the right position of a one element, and you make sure that things on the right hand side of this element are more, things on the left hand side are less, and therefore you have sort of partitioned your input into two separate inputs, yeah, with one element hitting at the right spot. I'm not going to go into details of the algorithms themselves. We don't, unfortunately, we don't have the time for all that. But the point being that you do have sorting algorithms which are much quicker than bubble sort, and these are Karthik, I'm not sure I follow this top to bottom comment, but maybe we can take this towards the end. So quick sort has a runtime of order n log n. Now the only difference with merge and quick is that quick is actually quick. There's always a constant factor to every runtime. Yeah, merge sort has a higher constant factor. You remember these different graphs that I had drawn? For example, this one, they're all quadratic in nature. But for example, I'll prefer this quadratic than this quadratic. Why? Because this is growing a bit more faster than this guy. Yes? So that's the difference between quick and merge. Quick is quicker than merge. Yeah. So now let's say you've sorted and you have used a sorting algorithm to do that. And after that, you have your input in this style. So, basically saying sort input, and this is what you get after that. Yeah. Okay. And this is the output. Okay. And so now the pairs that you really look at is 2, 4, 4, 6, 6, 10. So let's try to get to this point quickly. So we get rid of this double for loops. Maybe we keep one of the for loops because I have to type that anyways. So this time I want to generate. So the first thing that I'm going to do, I can take in a list because a list has something called as a sort function. You can sort an array also. Okay, and what I'm going to do is I'm going to now I'm going to say array dot sort. Yes, so it's sorted. Okay, this takes n log n time. And call it list actually, or we should call it input. Okay, so now in order to generate these pairs here, how should I iterate over these numbers? I should go from 2 to 6, right? So then I can generate 2 and 4, 4 and 6, and 6 and 10, right? So that's what I do. I go from I equals 0 to count -1, yeah. And when you generate these pairs, so for example, the way to, I can generate this pair by saying, okay, int first number equals, input I, and int second number equals input I plus 1, Should this be input count -1 or should this be -2? Sorry, -1, right? Because I want to come till 6 at least. Okay. And if we quickly print this just for our sake, console.writeLine, we generate this pair. And we generate this, this. So we say first number, second number. Let's run this and see kya there. You all are still with me, or I'm alone now? It looks like I'm okay. There are some. What happened? Okay, we need to create a list instead of an integer, instead of an array. Okay, let's run again. Right, so we generated 2, 4, 4, 6, and 6, 10. Isn't this what we wanted? Some light on this topic. You end up hiring. Sure, Prasanna, I'll do that. So you see, where were we? We did this 2, 4, 4, 6, and 6, 10. Yeah. So we are getting the right kind of. We are getting the right kind of pairs. Now the question is, what do we do further with this? So we got the numbers, we got the pairs that we want to inspect, and what is that we want to do now? We want to take the difference, isn't it? And we want to find the minimum of those differences. So everyone is gone very quiet now. So I'm perfectly fine if we want to conclude here and move on to the other topic. If because I think I can understand what company expects. Okay, fine. So what I say is that we should move on to the other topic, and then if there are still some of you who are interested in finishing this, I can stay with them for a bit longer.
Sir, first complete this, then move to another topic.
I am not sure, because I think there are some people I see who probably want to get to that second topic of what companies are looking for. Yeah, so I'm going to do this. I'm going to first sort of talk on this, and there are going to be questions and feedback, and then there are still, if there's energy left in you, we can finish this. Yes. Okay, so I understand your curiosity in this particular point. What are companies looking for? I'm not going to tell you anything magical about it. Yeah, so don't be overexcited. There's nothing that I'm going to tell you that you say this mantra during the interview and you'll be chosen. Nothing like that. Okay, so what companies are? What I would probably talk about me, and maybe there's some generalization to it. Yes. So what I'm looking for when I'm hiring candidates, I'm looking for someone I think has the hunger to learn. This is basically what I'm looking for. Yeah. So I sense always that you're doing the 6 months course. It's very aggressive in the sense there's a lot of topics that you have to finish. And my general idea is that I'm looking for someone who really tried getting some value out of this course. Yeah. So someone who has got their hands dirty rather than copying from their friends. And this is something, I'm not sure how much time do you have before your placements begin. But if you do have any time, then the only way, 1 month, cool. This is good enough time. The only way you can really impress the person sitting in front of you is not by telling me 15 different words that you know. Yeah. So I've seen typically, candidates trying to impress me with things like, they say all the jargons that they can think of. Yeah. And I'm never impressed with that. Yeah, I'm probably thinking nobody is impressed with that. It's very easy. Even my 6th standard kid can spend 15 minutes trying to get some jargons. Exam score, yes. So I'm getting some questions here, whether I look at exam score, previous technical background, improper English. So I'll take one by one. So exam score, yes, if there's a test that we do provide, then this is something that, it again depends on what kind of a test have we provided. I generally provide an algorithmic test, and I'm mostly interested in knowing whether the person actually understood what they wrote. Yeah, so I'm generally coming up with algorithms where I feel that, you know, I can really test their understanding of the matter, you know, because I know a lot of times what it's unfortunate, but I know a lot of time what candidates are doing, they are mugging up algorithms, some basic things, you know, they know TCS aa raha hai, TCS ka ye generally aise puchte hai. And then, you know, there's some cool guy who knows what kind of questions come in, and, you know, everybody sort of starts mugging those things, right? I would say don't take that approach. It will not take you very far. Yeah. Typically, you know, we always understand that. Yeah. So don't take that approach. You don't have to mug up everything, but, you know, whatever you know, you should really know. In the sense, you can write that thing even if you're woken in the middle of a night. Yeah. And this can only come when you put in your hard effort. Yeah. And not by mugging, but, you know, for example, take this algorithm. Yeah, you go to HackerRank, you know, take the simpler ones, and you say, I'm going to solve this one. I'm going to make it pass. I'm going to think of an algorithm. You know, I'm going to think of the sequence of steps. And it takes, you know, maybe this algorithm, for example, the one that we're doing, maybe it takes you 5 days to do it. Yes. But if you put in that hard effort and you're consistent about solving it, eventually you will get it. Yeah. Yes, let me come to that question, Pratik. So the exam score matters, and especially when I say exam score, it's the interview score. So if you're asking the exam score of CDEC, and then again, you know, I typically look for your algorithmic score. I'm not very happy with the way, you know, because I know most of these are theoretical now, rather than like the machine graded test where we truly test whether you can write an algorithm or not. The previous technical background, to a certain extent, you know, it might matter, and it's very subjective in nature. You know, some people would want excellent kids because maybe, you know, they don't have the time. They're taking a lot of you, and they don't have the time to really drill down and really understand whether the person with good marks is actually, you know, good at coding and actually understands things well. But I typically don't go by your previous technical background. I mean, that can be a filtering criteria because sometimes things are just unfortunate. You know, you like have 1,000 students, and, you know, there are logistic matters. There's, you know, we have to make a decision within some time. So it's unfortunate that, you know, we don't get to interview every single candidate, yeah, because that would take ages. So we have to have some criteria in place where we can filter them. You know, I know sometimes it so happens that we can lose on a very good candidate. Yeah. Improper English to me, it just doesn't surface. You know, I generally give my candidates a language they want to express themselves in. So at the start of the interview, I tell them Marathi, Hindi, Gujarati, Marwadi, and English. I understand 5 languages. If you can talk any of them, I'm happy. Yeah. So language really does not matter to me, you know, as long as a person can express themselves well in the mother tongue. Yeah. So obviously I don't know any South Indian languages, so that would be tough for me, but, you know, hopefully you can just speak Hindi or English or something, right? But again, you know, it doesn't matter that you have to speak really good English and try to impress the interview with your English, you know, because that's not what I'm hiring you for. Yeah. So I'm hiring you for writing code. Yeah. And you don't write code in English. Yes, you English to a certain extent in naming and all that, but what matters is whether you can really write a good piece of robust code which can work, and you can really design it for, you know, all sort of boundary cases and stuff like that. So that's what I'm testing. Yeah. Then there's also a question where it says, is it right that DS is most important? That's not. And so, you know, there's an interviewer's dilemma. Yeah. How do you end up picking the right candidate? Yeah. And a lot of topics, you know, it's easier to mug them up, and DS being the one that's the most difficult to mug up. Yeah. It's like, you know, we had English and Hindi and Marathi and history and geography, and then we had maths. Yeah. And then we had geometry. You know, so you can mug up all those other topics, but when it comes to maths, difficult, or geometry, even more difficult, right? So that's how I look at DS, you know, and that's the reason, you know, I focus mostly on DS, because that can truly tell me, you know, if a person is really excellent in thinking, you know, I'm pretty sure, you know, this person, even if it does not know database very well, you know, I give him like 2 months, and this guy, or this guy would really shine there. If he can think, he or she can think, I'm pretty sure he or she can do other things also well. So there's another thing that I typically look for is dedication. So I'm looking for candidates who are willing to put in the effort. So I do a very special interview. I call it so once I filter, I call it sort of an open book interview. So what I really do there is I give you a topic a priori. Yeah. So once you clear my first step, I give you a topic a priori. I give you some time to prepare on that. Yeah. So for example, I would say, and then I ask you a problem statement during the face-to-face interview, and I really grill you for like 3 hours. Yeah. This is where we take a problem statement and we together try solving that problem. So basic sort of a session that I'm doing right now. And what I'm really testing at that point is whether the candidate can stand that time with me. Because I'm not like this at that point. I'm very grilling at that point. I'm really testing, whether they can take my pointers and move ahead. So I'm the one who's watching, and they're the ones who's writing code. So this is where I really see whether you have the endurance and you are determined to do a certain task. So that is one of the most important aspect for me. Before when I hire a candidate, I want someone who is willing to put in the effort, endure it, and really has the desire to really solve that problem within that time, within that pressure situation. If you do that, I know this person will survive here. Right. I'm not sure if this is all very helpful. So do let me know if you have other questions, or if you think you want me to throw some light somewhere else. Yes, Sanket, I know you're saying Git basics, but Sanket, I really feel that I have done way over the scheduled time. I would very much want to do everything. I like coaching, teaching, mentoring, but I'm really sorry that we can't do Git basics now. I would at best try to finish off this half thing, this algorithm. Yeah. Maybe, I can talk to Keshav. Maybe we can do a session some other time. Yeah. So if you do still have the energy left, I would like to sort of finish this off. Can you please give me a confirmation quickly? If there's anyone who's interested, then I can finish it off, or else we call it a day. Okay, I see one person. Okay, is still write code at this position in your present company? That's a very interesting question. Who is that? Shubham. Hey, Shubham, very interesting question. So I'm looking at the responses and then I try to answer you. Yeah, so Shubham, I'm a very hands-on guy. It's very difficult to fool me in the interview. Yeah, I do a lot of coding even when I'm home. And I still write a lot of code. I do make a lot of presentations, and these two things don't go well together. So I do try to find my own time. What I do is I have a dedicated amount of time that I always spend in a week to upgrade myself. So I try to stay on top of all the technologies that we work on. I try to investigate into different things that are coming in the market. And this is a space that keeps moving and moves at an amazing speed. Yeah. So I do spend a lot of time reading. I also actually sometimes go and solve algorithmic problems still. I really enjoy that. There's a Euler.net website. You can have a look at it, where I try to, it's mostly maths-based questions where you can design, those algorithms are really very intricate. Yeah. It's called Euler.net, I believe. Yeah. Euler, EULER. Yeah. So yes, I do a whole lot of things, still very hands-on. Yeah. So for example, I do a lot with, tinker a lot with Dockers. I tinker a lot with IoT boards. I do a lot of Azure DevOps stuff. So yes, the short answer is yes. Yes, learning never stops. That's right. Okay, so I saw a lot of confirmations. So, let's finish this business. Yeah, where we just probably need some more time. Sort of bringing back the context, you have these pairs that we created. If you remember, we control. I need my specs again. Okay, so you see that we're getting the pairs right. Now the next step would be that we get the difference, isn't it? So now we say find the minimum difference. Yes. So how are you going to do this? We already have the pair in our hand. We know the first number and second number basically make a pair, right? So we can take the diff. Yes. And we say, because this is sorted, I know that the input I plus 1 is greater than input I, isn't it? So I can very safely do input I plus 1 minus input I. Yeah. Right? So that's going to give me the absolute difference, because I know input I plus 1 is greater than input I because I sorted those numbers. Yes. And now I want to get the minimum difference. So, we wrote this code. You remember this? What is that we wrote there? So we had the concept of a min diff. So imagine basically what you're doing. We are trying to find the minimum difference. So we say min diff equals input of 1 minus input of 0. Yeah. And instead of starting from 1, we start from 0, we start from 1 this time, right? Or we start from, so 1 minus 0 is already done, so we start from 2 actually, and then we want 2 minus 1 and so on. Everyone with me? Right? And then we write that same if piece that we wrote there. So we say if min diff is greater than diff, then we want to say min diff equals diff. Right? Let's try to print our minimum difference. Let's take the camera. So we say dollar min diff equals min diff. Let's run it. So min diff is 2. Prasanna, that wouldn't be less than, because I'm trying to find the minimum. So if I say less than, then I shouldn't be swapping, in fact, right? So if the min difference is greater than difference, then I want to set the min difference as the difference. Because I always want to keep the minimum difference as the minimum. Yeah. So it came out to be 2, which is sort of expected from these numbers. We say 2 4 ka 2 hai, 4 6 ka 2, and 16 ka 4 hai. So the minimum is 2. Yeah. And now it's a very simple job. We sort of iterate over this list again. Yeah, this time going from 1. And we say I less than input dot count, input dot count, and I say I plus plus, and what's the problem? Sorry, we should finish this for, and okay. Why we didn't use, because they were really not needed. I just did this to explain that concept. just wanted to show that, we have the pair. The pair is basically, so, that is input I plus 1 and input I. Yeah. Okay. So now I want to just, create this list of tuples, and I just want to populate it, right? So I say var result, or is we say, let's say for brevity, we say result equals list of tuple of int comma int, and okay, and then we start populating this. So we say, if first of all we check if the diff, we get this diff again. Okay, and we say if diff equals min diff, yeah, then I want this pair, right? So I'm going to say result dot add, and I'm going to add a new tuple, and the values in that would be input I, comma, input I plus 1. Okay. And eventually, instead of returning null, I'm going to return the result. Right? Let's see if this actually worked. We call var result equals this, and we write a for loop to just print it. Yeah. So we say for int I equals 0, I less than result dot count I plus plus. Let's see console dot write line, and this time we write the tuple. Yeah, so we say dollar and this and this, comma this. We say result of I, comma result of I plus, sorry, I plus 1. So which means I can't go up till count, क्योंकि count के बाद कुछ नहीं होगा. So, and we can now run this and hope for the best. Not nice. Where is the index out of range? Must be less than 914. 914. अच्छा वहाँ से call हुआ. So we are going from one. Sorry, here. Yeah, because right. Let's run again. Did we not print? That's very interesting. Okay. Okay, for some reason it's exiting. That means either there's an exception or something somewhere. Let's put a breakpoint. Let's try and understand what's happening. I do come here. Okay, that wouldn't be right, is it? That should be, okay, that should be from 0 then. But तो आ तो रहा है, बाद में क्या होता है? यहाँ पे भी आता है. Okay. So 2 mistakes first of all. Yeah, so you see that we want to print from 0 to, this is definitely, we're starting from I and I plus 1. So if we just have one pair, then result.count is 1 and I should be less than 0, which is obviously not right. Right. So I should be 0 and then should be less than the count. Oh, sorry. This is completely wrong what I'm writing here. It's still in that lower piece of code. In fact, you know, each of them is a tuple in the first place. So result I dot item 1, comma, result I dot item 2. So, you know, it's a tuple, isn't it? So what we've sent is a tuple. Okay, this should do it. And then there was a mistake here where we started from 1. We should start from 0. And this, I think, should do the trick. Yeah, so we printed 2, 4, and 4, 6. Okay, so you got any questions here? Any part of the code that's not understood? So, you know, what we tried doing here is we tried finding the minimum difference. Okay, we are trying to print only those tuple. Yes, that's correct, Prasanna. Okay, and we can take this off obviously now. We're not debugging anymore. And then we've written another for loop. So, you know, what we're basically doing is, if you go back to here, then, you know, we got these pairs. We found out that the minimum difference is 2. And then what we did is we went over these pairs again and we checked whose minimum difference is 2. So when we hit the first pair, we see the minimum difference is 2. So we take that and we put that into our result. Then we check 4, 6, uska bhi difference 2, we put it. And then we take 6, 10, the difference is 4. So we obviously do not put it here because this condition does not match. Yeah. And then we are eventually returning this. Okay. So I think in interest of time, I would like to sort of close here. We would have returned, you know, where's that Prasanna? Prasanna, I'm not going to do that. Precisely for the reason that, you know, I was preaching. Otherwise, you know, I'll be going against my own teaching. Yeah, the reason is there is no good thing that can come out of me sharing this code, yeah, unless you want to mug it up, right? So there's absolutely nothing good will come out of that, yeah, and it will rather you know, sort of go against the very stuff that I just said, that, you know, algorithms is something you shouldn't mug, right? So the good part about algorithm is you don't need someone else's code to know that you're right. Yeah, because once you're right, you know that yourself. Yes, that's the amazing part of it, right? So I would say, in fact, make it a point that you never take someone's code, never ever. Yes. Yeah, it's a tuple. You can write down the tuple thing. Yeah, and then you can search. There's a vast amount of stuff, literature on the net. Something. It's mind blowing. So if you just want to know about tuple, write the word tuple. Go ahead and find about it. Write a program involving tuple. Do something with it. Get your hands dirty. Yes. So that would be the only way to learn that concept. There is no other way. Yes, there's no way. Like somebody asked me, do I code today? And I said yes. That's because the only way I can be mentoring my team. Yes, or I can provide them guidance. As if I haven't got my hands dirty, I wouldn't know the nitty-gritties of things. I'd be just hearing things on a superficial level and then making decisions on superficial level, right? So I would say, sort of vouch to yourself that I will never take someone's code, because there is nothing good that will come out of it. Yes. So for that very reason, I'm not going to share this code. Yes, because it's very simple. You can go and search on Google. I'm pretty sure you'll find code somewhere or the other. Yeah, somebody would have solved it, and the solution would be available, right? But again, it's not going to help you in any way. Yes. So I would say what you all should do is basically you should take it as a challenge to yourself and say, I'm going to give myself 5 days and I'm going to write this piece of code in whatever language I'm comfortable with. Yeah, and you struggle with it. You struggle with it like crazy. Yeah, and in the end, when you do this, there is no satisfaction like this. Okay, and I'm telling you, the next algorithm you will not take 5 days. You'll take a day probably, right? So please, if there's something that can help you out of this session with me, is one thing that don't take somebody else's code. Try to write your own. Try to write your own. Absolutely, the logic would be the same. It's Java or PHP or Python or Haskell or ML or whatever language you think of. Okay, so I'm not sure if Keshav is still here. Keshav, I'm done. I'm not sure if there are any other questions. I don't see, so we can call it a day. Thanks for everyone for this wonderful participation. You really did not make this tough for me, so I really have to thank each and every one of you, for making it live.
Hello, sir.
Yes, you can get my email ID, and in fact, I'm hiring, so I have 6 open positions for freshers. You can visit my LinkedIn page and you can see the job description and everything. And if you guys want to contact me, you can contact me on this. You can also feel free to contact me on my email ID to everyone. I'm just sending it to everyone. Yes, that's my official email ID. You can contact me on this. You can also drop me a message on LinkedIn. I always make sure to reply ASAP. So if you do want to get in touch with me about the opportunity, you can do so. So thanks again, everyone. And thanks, Keshav, if you're here, thanks for giving me this chance. I really appreciate this. Thank you, guys. LinkedIn, yes, LinkedIn. Okay, you can search for Kapil Budhia on LinkedIn, but this is me. I did have hair at some point. Right, so this is me. And this is my LinkedIn page. You can see I'm hiring, and you can view the job. There's also another post that I've done, so you can look for my posts, and in there's a whole description of the job description. And if you do have any questions about that, you can call me. You can also share my number here. Yeah. So once again, thanks, and I think we can call this session off. Is there someone from CDAC management team here? I believe they've all left. Okay, cheers, bye. Bye, everyone.
Thank you, sir.
Yep, cheers, bye. Bye, everyone.
Hello.
Yes.
Hello, sir. I have one question. Sir, in the interview time, we are putting the multiple languages in our resume. So, sir, if we don't know the other language, means just like I know that Java and React, merge stack. But I am good in Java. I am not good in merge stack. So, sir, can I put the merge stack in the resume or not?
Yeah. So one of the things I find a bit irritating is when I see a resume and there's like 15 things mentioned in there,
Yes.
saying, you know, I know this and I know that and I know that. And then I try to question on one of those things and they say, ye kabhi to padha tha, abhi yaad nahi hai.
Yes, yes.
And then you try to ask on something else and then say they don't know what they wrote. So I would say, you know, I typically don't write things that I don't know. Yeah. So if you think you have a level of knowledge there, you don't have to be an expert there, but if you do have a level of knowledge to, you know, hold a conversation on that topic. Yeah. So maybe you may not tell me the intricate details. Maybe you cannot solve a problem in there, but, you know, you do have a working knowledge of that stuff. And then it is safe to mention. But just because you think, you know, you caught your friend talking about Blazor and then you thought, oh, Blazor sounds cool, let me write it down. I would say don't do that.
Yeah, yes. Okay.
Yeah.
Thank you, sir. Yeah.
Okay. Okay, sure. Cheers. Bye, everyone. Have a good weekend and a good placement season.
Yes.
Bye.
Thank you, sir.
Thanks a lot, sir.
Bye. Bye.
Thanks a lot, sir.